Okay, Cramer's rule is one additional method for solving linear systems, and it requires that you use multiple determinants to find the solution to the system. So just obviously a quick review of our basic vocab, that kind of thing. I want to remind you that if these are the coefficients to your equations, then those would go in here in your coefficient matrix. And that's something we've been utilizing every day, so I don't think that's anything new. Okay, so what we're going to do is we're going to find three determinants. Capital D by itself is the determinant of that coefficient matrix that we are going to set up. Okay, now I want you to notice there's two additional determinants. Here's the determinant for x and the determinant for y. And it says here, it says replace the coefficients of x and y with the constant values. So I want you to notice the previous system was ax plus by equals, what was it called? It was called E. And then it was cx plus dy was equal to f. And so here's our coefficient matrix, right? A, B, C, D are all in place. And what they have done is when you're solving for x, they're going to take this x column right here and they're going to replace it with the constants from the other side of the equations. Okay? When you are solving for y, what they'll do instead is they'll take those coefficients, the y coefficients, b and d, and they'll replace them with the constants. So you notice that that column got replaced. And then what they're going to do is they're going to set up two fractions. Both fractions use the same determinant in the denominator, so you will only have to do the actual number crunching, the multiplying and subtracting once, and then it's going to do the x determinant on top to find x, and it does the y determinant on top to find y. Now, you need to make sure you pay attention. Neither denominator, because they are the same thing, neither of them can be equal to 0, because remember what it means when our coefficients matrix has a determinant of 0, okay, and that means that you either have infinite solutions or no solution. That means you can't use this method to solve it. That's all it means. You don't know which it is, infinite or none, until you find an additional way to solve it instead. Okay, so here's an example that we're going to do. We're going to set up our three determinants. And I'm going to go ahead, I don't want to set them up and then also transfer them to the fractions. So I'm just going to set them up when I'm doing my fractions. Okay, and I want you to notice something. Watch what I'm going to do. I'm going to set up a determinant for the denominator, set up a determinant for the numerator. When I'm solving for y, I'm going to set one up for the numerator, but I'm not going to set one up for the denominator, because whatever number I get right here, I'm just going to transfer right there. I don't need to recalculate the determinant, the coefficient determinant. Okay, so my coefficients are 2, 1, -3, and 4. Okay, and that's what's going to make up the answer for both denominators. The numerator, when I'm solving for x, I'm going to take this determinant down here and I'm going to replace the x column. So the y column is still going to be -3 and +4. But I'm going to replace the x column with the constants, -9 and +23. When I'm solving for y, I'm going to take this determinant from the denominator and I'm going to leave the x column 2 and 1, and I'm going to replace this y column right there with the constants. So -9, +23. And now I have three determinants to calculate to get my answer. So when I do my forward diagonal, -9 times +4 gives me -36, minus, and then my backwards diagonal is -3 times +23, which is -69. And then because it is minus and negative, it does become addition. Okay? And then I'm going to set up the denominator as well. When I do my forward diagonal, 2 times 4 is 8 minus, and then the backwards diagonal is negative 3 times 1, which is negative 3, which once again is going to become a plus. So what I have on top is 33, and what I have on bottom is 11. And 33 over 11 gives me a solution for x of 3. So just one more determinant to go. I'm going to do the numerator for the y's. So when I do the forward diagonal, 2 times 23 is 46 minus, and then I do the backwards diagonal, and negative 9 times 1 is negative 9, becomes addition. Again, the denominator is the same 11 that I just calculated up there when I was solving for x. That's not going to change. So this time around what I have is I have 55 over 11, which is 5. And that means the solution to this system is the point 3, 5. And you could plug that point into both equations and prove that it does work. It is the solution if you wanted to. Okay? Now remember, once we move into these 3x3s, you're going to be relying on your calculator. So if you have a calculator to use at home while you're watching this, that'd be great. If not, you'll have one in class. So when we have a 3x3 system, here's all of our coefficients again. So of course there's our coefficient matrix, and that coefficient matrix will make up the denominator, and we will calculate its determinant for the denominator to solve for all 3 variables. Okay, so here's essentially the same setup. Your denominator is still just capital D. It's your coefficients matrix determinant, and it can't be equal to 0. So same setup, same rules. When you're solving for x, you're going to use the x matrix determinant. Solving for y, you're going to use the y, and solving for z, you're going to use the z. And the same thing occurs. What happens is that all 3 of these determinants up here, they start out looking like this one, and one of the columns gets replaced. And which column gets replaced just depends on which variable you're solving for. So you notice here in this x determinant, it was this x column right here that got replaced with the constants. When we're solving for y, the y column of our coefficient matrix got replaced with the constants. And of course, last but not least, when we were solving for z, the z column of our coefficient matrix got replaced with the constant values. Okay, so the final example just says write the determinants. Okay, it says determine if you can have a solution with Cramer's rule, which means we just need to calculate the value of d. And it says to do it without using a calculator, so we get that extra practice. But we're not actually going to solve the system because it just said write the determinants. We're not actually calculating 3 of the 4 determinants here. We're just setting them up, writing them down. Okay, so if I'm going to solve for x, okay, I'm going to have a determinant on bottom. No, I don't think I left myself enough room. Okay, let's move it down. Okay, I'm going to have a determinant on bottom and a determinant on top. Okay, and the determinant on bottom will be all of my coefficients. So I will have a 2, a -1, and a 3. I will have a 1, 1, 1. And I will have a -1, 5, and 2. There's my coefficient determinant. Okay? Because I'm solving for x now, I'm going to leave the y column and the z column completely untouched. And I'm going to replace the x column with the constants. So the x column is going to become 13, 2, negative 5. So that means I've written what my d of sub x is, and I've written what my d is. This is the one we're going to calculate here in just a minute. Okay? And then I want to go ahead and write dy, which would be the numerator when I'm solving for y. And I want to write dz. So the numerator when we're solving for y is going to, once again, it's going to start out looking like this. But it's the y column that's going to get replaced. So the x column is going to stay 2, 1, negative 1. And the z column is going to stay 3, 1, 2. But this time, it's the y column that gets replaced with the constants 13, 2, negative 5. Okay, so that's it. We're just writing it. We're not actually calculating it. And then dz, once again, is going to start out looking like our coefficient array. I'm going to leave the x column alone. I'm going to leave the y column alone. And this time, it's going to be the z column that gets replaced with the 13, 2, and negative 5. Okay? So the one final thing that we need to do to finish this problem is we need to actually calculate this d right here in this denominator, because we want to know it, we want to make sure it's not equal to 0, because otherwise we could not use Cramer's rule to actually solve it. Okay, so I'm going to go ahead and I'm going to erase what's down here at the bottom so that I have the room to actually do that, and also what's here. Okay, so remember that when we're doing a 3 by 3, what we want to do is we want to take our first two columns and copy them. So 2, 1, negative 1, there's my first column copied to the right of the arrangement, and then negative 1, 1, and 5. And now I can do my 6 diagonals to calculate my determinant. So my first forwards diagonal right there is 2 times 1 times 2, so I get 4, plus my second forward diagonal is negative 1 times negative 1, which is 1, plus, and then my third forward diagonal is 3 times 1 times 5, which is 15. So there's my 3 forwards diagonals. And now I'm going to put a minus because now I'm going to start my backwards diagonals, and they're all going to get subtracted. So my first backwards diagonal is negative 1 times 2, which is negative 2, which of course is going to become a plus. And then my next backwards diagonal is still going to get subtracted, and 2 times 1 times 5 is 10. And then a minus for the final one. And the final one is 3 times 1 times negative 1, which is negative 3, which will again, of course, become a plus. Okay? And when I add all that up, and I do 4 plus 1 plus 15 plus 2 minus 10 plus 3, I end up with a determinant of 15. And so that means that I know the denominator for all 3 fractions if I were to use Cramer's rule. And I also know that this system can actually be solved using Cramer's rule. Okay, but that's as far as the problem asks us to take it. Okay, you want to practice doing these in your calculator too, because you will be using Cramer's rule to solve a 3 by 3 system, but of course with the assistance of your calculator. So you can practice that in class. Thanks, and see you guys in class.